Imagine you are looking up at the night sky. 1,000 stars shimmer silently above. Some are already dead, their light only now reaching us. Some are being born as you breathe, hidden in the clouds of galaxies you can't even see. And somewhere, far beyond the edge of sight, space itself is stretching, getting bigger, faster, stranger. What if all of this, the stars, the galaxies, the very fabric of the cosmos, was on a ticking clock? What if the universe ends? It's a question so vast, so eerie, that for most of human history we did not dare ask it. But we are asking now. And for the first time in history, we're beginning to answer. The story starts, as all great stories do, with a beginning. Not just a beginning of life or light or time, but the beginning. Roughly 13.8 billion years ago, the universe was born in what we call the Big Bang. But it wasn't a bang like an explosion in space. It was the creation of space itself. In a trillionth of a second, everything, matter, time, the very rules of physics emerged from a single, infinitely dense point. At first, it was too hot for atoms, too dense for light. There was no color, no sound, only chaos. But as it expanded, it cooled. Hydrogen and helium formed. Then, after about 380,000 years, the universe became transparent. Photons, the particles of light, were finally free to move. That light is still around us today, faint, cold, but measurable. We call it the cosmic microwave background, a baby picture of the cosmos, still echoing from the dawn. Galaxies took shape slowly. Stars ignited like candles in a dark room. In the great drama of time, some galaxies formed faster than we thought possible. In 2025, astronomers were stunned to discover MOMS-14, a massive, mature galaxy that existed just 280 million years after the Big Bang. It shouldn't have been there so soon, but it was. The universe was evolving fast. Billions of years passed. Stars burned, died, and gave birth to new elements. Supernovae seeded the cosmos with carbon, oxygen, iron, the building blocks of life. Planets formed. And in a quiet corner of a mid-sized galaxy, a small rocky world called Earth began its spin around an average yellow star. We humans arrived late to this party. We showed up just over 4 billion years ago and started asking questions almost immediately. What are stars? Why do they move? How far do they go? In 1998, we found one of the strangest answers yet. The universe is not just expanding, it's accelerating. Some unknown force is pushing the galaxies apart faster and faster. We called it dark energy, and we didn't understand it. By 2025, new telescopes and surveys gave us more clues. The Dark Energy Spectroscopic Instrument DESI mapped over 15 million galaxies, each a flicker from deep time, and what it saw shocked researchers. Dark energy might not be constant. It might have peaked billions of years ago and is now weakening. That revelation did not just shake our understanding, it changed the entire forecast for how the universe could end. Because, you see, there isn't just one way this all could end. There are 4. Each is real. Each is based on our best science. Each is a future we might face. The most well-known is the Big Freeze. In this vision, dark energy continues its reign. It keeps pushing galaxies farther apart, faster and faster, until even the nearest star becomes invisible to us. Over trillions of years, stars die. New stars stop forming. The last lights wink out. Black holes evaporate through Hawking radiation, shrinking slowly, faintly, until they vanish. What's left is cold, quiet, forever. A graveyard of particles drifting in darkness. But what if dark energy does not last? What if it fades, as DESI's data hints it might? Then gravity could take back control. Expansion would slow, then stop. Galaxies would begin to fall toward each other. Stars would collide. The entire universe could collapse into a single point, the Big Crunch. It would be unimaginably hot and dense. Some physicists think it might even rebound in a new Big Bang, in a cycle. Bang. Crunch. Bang again. A cosmic heartbeat, too slow for human time, but pulsing nonetheless. Then there's the Big Rip. A scarier end. A faster one. This future begins if dark energy does not just push, it pulls with growing force. If it crosses a threshold and its pressure goes below what physicists call -1, it becomes what's known as phantom energy. Galaxies would rip apart. Stars and planets wouldn't just drift away, they would disintegrate. Our solar system would tear loose. Earth would be shredded, the atoms themselves unbound. Eventually, even the fabric of space-time would be torn open. Nothing could survive. The entire universe would be ripped to shreds in a final, violent instant. The latest data says this is unlikely, but it's not impossible. And then there's the strangest ending of all. One not of fire or ice, but of evaporation. Until recently, scientists thought white dwarfs and neutron stars, the corpses of stars, were eternal. But in 2025, physicists from Radboud University proposed a quantum mechanism by which even these ancient remnants might slowly decay. It would take time. So much time, 10 to the power 78 years or more. But eventually, every star, every black hole, every atom might just vanish. Not explode, not collapse, just evaporate into silence. 4 endings, 4 stories, each one grounded in what we know today, and each one subject to change. Because the truth is, the universe is still writing itself. We live in a golden moment. The stars still shine. Galaxies still swirl. The sky is full of motion, full of drama. But it won't stay that way. Already, the night sky is subtly dimming. Already, galaxies at the edge of our vision are moving beyond the cosmic horizon, disappearing forever. We will never see them again. In 100 billion years, if anything still watches the stars, there will be no galaxies in sight beyond our own. No way to know the universe was ever more than a cold, lonely island of dust. But we are here now, at the center of the story, the only known observers of this vast cosmic play. And so we wonder, what comes next? If the big freeze is real, then time itself stretches into infinity. The lights go out, one by one, until only memory remains. If the big crunch comes, the story ends in a full stop only to begin again. If the big rip is true, there is no time to say goodbye. And if quantum evaporation rules, then the end is not a bang or even a whisper, but the gentle unweaving of all things. And yet, the deeper question remains. Does it matter? We will be long gone before any of this happens. Earth itself will be swallowed by the sun in about 5 billion years. Whatever we build, whatever we dream, whatever we become will happen in a cosmic blink. And yet we ask, we wonder, we look to the stars, because the story of the universe is also the story of us. We came from the same elements that forged in stars. We are the iron in blood, the calcium in bones, the carbon in breath, all once born in stellar fire. We are not separate from the universe. We are its thinking, questioning, dreaming part. The universe may end, but its video is still unfolding, and we for now are here to tell it. So look up. The stars are still speaking, and the next chapter is just beginning. What if the universe ends? Maybe it will, maybe it won't. But while it lasts, we listen, and we wonder what comes after. And that is the video of how the universe might end. So if you enjoyed this journey through space and time, don't forget to like and subscribe. Until next time, keep looking up, keep wondering, and keep reaching for the stars.